Hello everyone, it's math time. We're going to start with number 1, which I can't get Zoom to work, so I'm just going to use some note cards, but I'll put it up to the screen so you can see it. But problem 1, a used car dealership collects data on the selling prices of cars and their ages in years. Based on a sample of cars of the same model, the least squares regression line for predicting price in dollars from age in years is, as you can see, this is the formula right here. So later we're just going to plug in some numbers. What does the slope of this line say about the relationship between price and the age of the car? Since the slope is negative, it's going to mean that the price goes down as the age of the car increases. Just because it's negative, so it's going to keep going down as the years keep going. Yeah, that's the relationship. And then for for number 2 of number 1, what is the predicted price when the age of cars is 0 years? How would you interpret this value? It would be $18,500. And that's because if you plug in 0 to this formula right here, if you plug it into X and you multiply 1,250 times 0, then that's 0. And you'll do 18,500 minus 0. So that just gives you 18,500. And then for 3, you, instead of putting a 0, you would just plug in a 5 instead, and that equals, as you can see on my little C thing right here, you just plug in 5 right here, and that is going to get you $12,250. And then for 4, would it make sense to use this model to predict the price of a car that is 25 years old? Why or why not? I said no, because if you put 25 years in, it would be less than 0. And you can't pay less than 0 for a car. So no, it would not make sense. And yeah, it would not make sense. And then number 2. Fuel consumption Y of a car was recorded at various speeds, X. Fuel consumption is measured in miles per gallon and speed is measured in miles per hour. Software output gives the least squares regression line as this right here. I thought I wrote it down. Wait, that's 4. Yes. This right here, that's the formula. And the data is there too. Make a scatter plot of the observations and draw the regression line on your plot. So since it's it looks like it's a decrease. Yes, it's a decrease. It's a negative slope. So the regression line is going to be down. It's going to be negative. So this is my scatter plot right here. Ignore this one for now. We'll get back to that later. But we got speed here and fuel. I didn't put all the numbers, but the top is, the highest number for fuel is 65 and the highest number for speed is 80. So yeah, this is what it looks like based on the data. And then, would you use the regression line to predict Y from X? I would say no. It's not very linear. There's a huge outlier right here and influential place right here. If it was more towards here, then it would be, like, the data would be more, what's it called? Just, like, closer together, I guess. The correlation would be stronger. That's what I meant to say. Yeah, but as you can see, it's kind of all over the place and is not very reliable. So no, I would not use this. I'd use like a quadratic. I'd use something else. For 3, verify the value of the first residual for X equals 20. Verify that the residuals have some 0 up to round off arrow. So yeah. You would just do the same as earlier. You would plug in 20 to the formula. You just put 20 right here. And that would get you 63.663. And then you would do the formula Y minus Y with the little triangle thing on top. And that is going to be 49 since the Y for 20 is 49. So you're going to do 49 minus 63.663. That equals negative 14.663. And that's rounded up, that's negative 14.67, which is the residual for that first line. So yes, we just checked it, and that is that. And it makes sense because it's negative and it's a negative residual. So that also helps. And then verify that the residuals have sum 0. The round off error, as you can see, I rounded off the number. And even the rounding can make it not exactly 0, but it's still reliable, even with the round off error, because you can usually tell if it's not that big of a difference. And then 4, make a plot of the residuals against the values of x. Draw a horizontal line at height 0 on your plot. How does the pattern of the residuals about this line compare with the pattern of the data points about the regression line in your scatter plot from part A? So we're going back to the graphs. Here is the line at 0. The top here is 10, and the top here is 80 again. But as you can see, it's really similar to the scatter plot. Like, the points are all pretty much in the same places. There's a big outlier right here. It's kind of like curved. Yeah, it compares very well. It's very similar. Yeah, that's number 2. 2 more. Number 3. A company retains a psychologist to assess whether job applicants are suited for assembly line work. The psychologist classifies applicants as one of A, well suited, B, marginal, or C, not suited. The company is concerned about the event D, that an employee leaves the company within a year of being hired. Data on all people hired in the past 5 years give these probabilities. So here just make sure, yeah. I wrote them down right here. Here are the probabilities. Just take a quick look. Okay. So for number 1, sketch a Venn diagram of the events A, B, C, and D, and mark on your diagram the probabilities of all combinations of psychological assessment and leaving or not within a year. So I did leaving. So it's a weird looking graph. But here's A, B, and C. I forgot to write D on here, but you see these lines and this line right here. That is going to be D, the leaving part. So that is going to be 0.1, 0.1, and 0.2 for C. And how I got that was, if you do 0.4, or for A, if you do 0.4 minus 0.1, and you would do that because A intersect D, the probability of that is 0.1, so you would subtract 0.4 from 0.1. That's going to give you 0.3. And since I'm doing that's the probability of staying. So the probability of leaving would be 0.1. And then for B, you would do 0.3. Yep, 0.3 minus 0.1. That's 0.2. And since B is only 0.3, you would subtract that. You would subtract 0.3 from, or 0.2 from 0.3, and that would also give you 0.1. And then C, you would do 0.3 minus 0.2, and that is 0.1. And then since C has 0.3, you do 0.3 minus 0.1, and that's 0.2. So that's how I got that graph right there. And again, this is D. D, D, D. Second part of that, what is the probability of D? The probability that an employee leaves within a year. This is easy because since I did this is the probability of them leaving, all you would do is add these all together, and that would give you your probability, which is 0.4 right there. So yeah, that's pretty easy. And then last question. A striking trend in higher education is that more women than men reach each level of attainment. The National Center for Education Statistics, which classifies all subjects as male or female, provides projections for the number of degrees earned, classified by level and by the sex of the degree recipient. Here are the projected number of earned degrees in thousands in the United States for the 2027 through 28 academic year. So if you choose a degree recipient at random, what is the probability that the person you choose is a man? So this is pretty easy. All you would have to do, since it's a degree recipient at random, probability that it is a man. So all you're going to do is you're going to find the total number of men in the whole entire graph, which I'll actually show you this one. It's right here. I hope you can see it. But you're going to go to the however many men there are, which in this case there are 1657 men, and you're going to divide that by the total. So if we do 1657 divided by 3990, I'll do 1657 divided by 3990. That is going to give you, one sec. That is going to give you, yes, 0.415. And then I just round up to the nearest whole number, so that's going to be 42%. Yeah, that's pretty easy. And then number 2, what is the conditional probability that you choose a man given that the person chosen receives a master's? So instead of using the whole total this time, what you're going to do is you're going to find you're just going to go straight to the master's column, find the male section, and then divide that by the total number of master's degrees. So in this case, there are 340 men in the master's column, and there are 813 total in the master's column. So you're going to divide 340 divided by 813. That gives you a similar answer. Yes, if you round it up, it's just going to give you 42% again. So very similar. And that's with rounding. And then last question. Are the events choose a man and choose a master's degree recipient independent? How do you know? This one's a little bit more tricky. What you're going to do, you are going to do the probability of A intersect B. So what you're going to do, you're going to see, in this case, A is choosing a man, and then B is choosing a master's degree recipient. So you're going to go through the column and see which place intersects. So in this case, in the master's and in the male section, there's 340. That's what matches up if you just kind of do that. So you're going to do 340 divided by the total this time. And that is going to be 0.0853, as you can see right here. 0.0853. Then you're going to individually find the probability of A and the probability of B. In this case, it's choose a man and choose a master's degree recipient. So for choose a man, you're going to go back and do the 1657 divided by 3990, and that's 0.415, as we saw earlier. Probability of B is going to be 813 this time because that's the master's degree. 813 divided by 3990, that's 0.204. And then you're going to multiply the probability of A and the probability of B together. So 0.415 times 0.204 is 0.0847, right there. And the intersect probability was 0.0853, and then this was 0.0847. So it's very, very similar, which means that they are independent since it didn't really make a big difference. So that's how you know that it's independent, if they're super close together, like the intersection probability and the multiplication probability. So, thank goodness. That's all done. Have a great day.